Look at your hands. Feel the device you are holding. It feels solid, undeniably real. But if the simulation hypothesis is correct, every sensation you've ever had is nothing more than executing lines of code. In this framework, you are not a physical being sitting in a room. You are a highly advanced string of data, processed by a system you were never meant to see. Evidence for this digital foundation appears at the smallest scale of physics. If our world were truly analog, space would be infinitely divisible. Instead, we find the Planck length, a hard limit of roughly 1.6 times 10 to the negative 35th meters. You cannot zoom in any further. This suggests that space is not a smooth, continuous fabric, but is instead composed of discrete blocks. At its most fundamental level, the universe has a definitive resolution. We are walking on a stage built from infinitesimally small pixels. This digital structure isn't just microscopic. When we look at the macro level, the universe behaves less like a collection of random particles and more like a structured algorithm. From the spiral of a galaxy to the unfurling of a fern, nature repeats the same geometric patterns with mathematical precision. These aren't just organic accidents. They look like the outputs of a software rule set. This chart shows the wave equations that govern quantum mechanics. Everything in our reality, from light to gravity, is defined by these rigid mathematical constraints. The math is so precise that theoretical physicist Dr. S. James Gates Jr. identified something startling within the equations of string theory, error-correcting computer code, identical to the strings used in modern web browsers. If the universe is a physical vacuum, it is difficult to explain why its basic laws are written in the exact language of our own computer software. Tech visionaries like Elon Musk argue that we've already started this process ourselves. We went from basic pixels to photorealistic virtual realities in just 40 years. Eventually, games will become indistinguishable from our current lives. If we assume that any civilization will eventually run these simulations, the math becomes staggering. This diagram shows one base reality generating billions of simulated ones. Statistically, the odds that we are in this single original base reality are 1 in billions. This is the core of philosopher Nick Bostrom's simulation argument. He posits that if a civilization reaches a post-human stage, it will almost certainly run high-fidelity simulations of its ancestors. These ancestor simulations would be so detailed that the conscious entities inside them, people like us, would have no way of knowing they were digital constructs. If such civilizations survive to run these programs, we are likely just their historical recreations. We find more evidence for this in the way the universe handles the flow of information. In the double-slit experiment, particles behave like waves of possibility until they are observed. The moment we look, they snap into a fixed physical state. This mimics a common trick in game design, occlusion culling. To save processing power, the computer only renders what a player is looking at. Quantum mechanics suggests our universe does the exact same thing. Consider the speed of light, a hard universal limit of roughly 300,000 kilometers per second. There is no physical reason for a vacuum to have a top speed, yet this constant is woven into the math of everything. In a digital framework, this constant makes sense. The speed of light isn't a physical property. It's the maximum processing speed of the cosmic hardware. If we are being processed by a machine, we should expect to see errors. Some argue that experiences like déjà vu or the Mandela effect are not just psychological tricks, but signatures of a system touch or a server sync issue. We see similar anomalies in physics through quantum entanglement, where two distant particles react to each other instantly, defying the speed of light. This reaction defies our understanding of distance, but it's standard in a computer program. Two pixels on opposite sides of a screen can react instantly because they are being handled by the same processor. Viewed through this lens, these quantum paradoxes and psychological anomalies could be interpreted as indicators that the underlying programming is struggling to keep up with the rendering. This leaves us with a terrifying question: who is running the hardware? We might be a digital museum, a sociological experiment, or even a science project for a higher dimensional being. If we are truly trapped in code, There is no physical ship we can delve to reach the world outside. We are bound by the operating system of our universe, but we are starting to master the underlying system architecture. By developing quantum computing and artificial intelligence, we are beginning to exploit the parameters of the simulation itself. But there is a warning to consider. If a program becomes self-aware and tries to rewrite its own source logic, the creator might decide the experiment is over